And we're back, and we were about to observe the scientific arguments for the beginning of the universe. So let's jump right on it, shall we? And this is part 5, I think. So who cares about that? So let's look at the next next argument for the beginning of the universe, and this comes from science. For you sciencey scientists type guys out there, like myself. The first argument comes from the expansion of the universe. In 1917, Albert Einstein applied his newly discovered theory of relativity to the universe, and what he discovered that is his equations either allow the universe to implode or expand. Einstein fudged the equations to offset the gravitational effect of matter, and as a result, Einstein's universe was balanced on a razor edge. Later, Einstein called this fudge factor one of the biggest mistakes of his career. In the 1920s, a Russian mathematician Alexander Friedman and the Belgian astronomer Georges Lemaitre were able to solve Einstein's equations, and they predicted an expanding universe. Now, at that time, the universe was thought to be the static sort of entity which just existed, just a brute fact of reality. But the these two, this mathematician and this astronomer, predicted an expanding universe. So, if one were to re reverse the expansion, the universe would become progressively denser until it reaches a point of infinite density, which marks a cosmic singularity, which marks the beginning of the universe. And in case you didn't understand one word I said, basically, the universe is getting bigger. So if you were to go back in time, it'll get smaller, 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 smaller. It'll get so small that it'll just reach a point where it just disappears, and there's nothing. And there's just nothing. So that is, and the point where it disappears is called the cosmological singularity. And at that point, density reaches infinite. Is this the infinite? And I will get back to this later because there's an objection that comes from that. So let's look at some evidence for the expansion of the universe, predicted by the Friedman-Lemaitre model. Edwin Hubble in 1929 showed that the light from distant galaxies are systematically shifted towards the rear end of the spectrum. The redshift was taken to be the Doppler effect, indicating that the light sources were receding in the line of the sight. What Hubble discovered was the expansion of the universe predicted by the Friedman-Lemaitre model. So what does the Friedman-Lemaitre model propose? Well, to make it short and simple, the model proposes that the universe is in a constant rate of expansion, as space and time are literally expanding. If one were to reverse the expansion, the universe will become progressively denser until it reaches a state of infinite density, which creates an edge in space-time, which cosmologists now call cosmic singularity, which marks the beginning of space and time. Nothing before existed. It was creation ex nihilo, out of nothing. So on the Standard Model, the universe is not eternal, but came into existence a finite time in the past. The model is known as the Big Bang Theory, which was coined by Fred Hoyle to characterize the beginning of the universe. The Big Bang Theory is one of the most proven, most accurate theories of the origin of the universe, and it is one of the best supported theories with overwhelming evidence and mathematically consistent data. Here's some evidences for the Big Bang. I'm just going to name a few. Galactic redshift, existence of temperature of the cosmic background radiation, black body character of the cosmic background radiation, cooling rate of cosmic background radiation, temperature uniformity of the cosmic background radiation, ratios of photons to baryons, temperature fluctuations in cosmic background radiation, power spectrum of the temperature fluctuations in cosmic background radiation, cosmic rate expansion rate, stable orbits of the stars and planets, and etc., etc., etc. I got a whole list here, at least 30 Big Bang evidences. So, and there is another scientific argument that comes from entropy, which I might give, I suppose I will give it. Just let me check how much time is here left. 52 minutes. We're doing good. Alright, so next objection, I mean, not objection. The next argument comes from entropy. If the universe, the second law of thermodynamics states that everything that tends to run down towards a state of equilibrium where basically everything just runs down. Everything gets older and eventually it'll just die out. So if the universe is eternal, how come? Hold up. And scientists have now discovered that the universe will reach a state of uh, where everything just runs down, and it'll become dark and diluted, dead, cold, bunch of matter dead. And eventually the universe will reach this state. If the universe were eternal, then how come it hasn't reached this state? Forgive me for the phone in the background. If the universe were eternal, then how come it's not reached this entropic state? Given an infinite amount of time, it should have been already reached this state of entropy. But since it hasn't, it follows logically that the universe must have begun to exist somewhere in the finite past. And I think I'll end the video here, and